Assalamu alaikum everyone. I welcome you all to the first lecture of this tutorial series on design of steel structures in SAP 2000. In this lecture we will see the basic modeling techniques and the definition of materials, the definition of frame sections, and how to assign basic grids. Uh, so let's get started. Let's start with a basic and easy structure at first. We will just look into the modeling at this stage. So the ground floor plan is in front of you. You can see the length of the structure is 20 meter and the width of this structure is 10 meter. The height is 5.5 meter. This structure is a basic shed, and at the roof level it is supported by a corrugated sheet. This corrugated sheet will be supported by the purlins which will run in this longer direction, and the purlins will be supported by the beams, by the main beams which will run in the shorter direction. So just to get an idea of the structure, you can see it will look something like this. The main sheet will rest on these cold form purlins, and these purlins will transfer their load onto main beams which are along the shorter direction, and the tie beams will uh, be along the longer direction. These column sections and beam sections are actually I sections. So let's get to the SAP model and see how to model them. Once you open your SAP model for the first time, you will see these options are frozen. So you will click on file and then click on new model. You can see this window appears in front of you. Since we are working in meters and kilonewton, so I will keep my units in kilonewton and meter at the moment. I can always change them at a later stage from this bottom right corner, and I want my default materials to be in Euro code, so I will select Europe here. We will also see some other options ACI code in the next lectures. For the time being I will keep it as Europe. There are some built-in default templates available in SAP, but usually I just click on blank and model my own grids and structure. So I will click on blank option here. A couple of windows will appear in front of you. We can close this window for now, and you can see the axes which are X, Y and Z axis in front of you. Now to start with, I will just model my basic grids, which are grid 1, 2 in X direction, and in Y direction I have grid B and A. So what I will do is I will right click in my model anywhere and click on edit grid data. I will click on modify show grid system, and here you can see I can add my X grid data, Y grid data and Z direction grid data. I want to add a couple of grids in X direction, so I will click on add twice. Now you can see these two grids appear. I will name them as 1 and 2. The ordinate of 1 is 0 meter and the ordinate of 2 is 20 meter. You can see from this drawing the grid 1 ordinate is at 0 and grid 2 is at 20 meter, and similarly grid B is at 0 and in Y direction grid A is at 10 meters. So I will add my grids in Y direction as well. To match with the drawings, I will name them as grid B at 0 and grid A at 10 meters. Similarly, I will add let's say I want to add a 0 level at 0, and in Z1 I will add my elevation as 5.5 meter, which is the elevation of the shed. I will click on OK and then again OK, and then I will just press this 3D button, set default view to 3D, and you can see now grids are visible in front of you: grid 1, grid 2, grid A and grid B. So now to model the structure, first we need to define our materials for the frame sections. Some basic materials are already given or defined by the client that what to follow, but for this structure what I will do is I will go to define, click on materials, and in this list you can see a couple of materials are already given. The first one is concrete and the second one is S355 grade steel. If I click on modify show material, I can see all the properties of this particular material, which is S355. So it has a yield stress of if I click on Newton millimeter, it will show me the yield stress in megapascals, which is Newton per millimeter square. I can change my units from here anytime. So I will just click on OK, and for this particular structure I want my material to be S275 grade. So I will click on add new material and I will change my region to Europe. Since this S275 is a Euro code material, so I will change my grade from this option from 355 to 275. Then I will click on OK, and you can see this material is added. I can show you the properties. Okay, one more thing I usually change is the unit weight is actually 7850 kg per meter square. The mass and unit weight is 78.5, so I usually change it to 78.5, and rest of the options let them be as it is. The yield stress of grade 275 is 275, so we will not change them. Click on OK and again OK. Now in the third step I will define my beam sections and column sections. So I will go to define again and click on section properties, then frame sections. Here you can see currently no frame section is defined, so I will okay, at this point I have two options. I can either import a new property from the standard sections which are already provided in SAP 2000, or I can add a new property and put in my own values, which may or may not be standard values. So we will see both options one by one. First in this lecture we will just use this option, which is import new property. I will click on this, and here by default already steel is selected, which is okay. Here you can see there are multiple options: heights section, channel sections, angle sections, tubes, pipes. For this structure we are using I section, so I will click on this one and I will select my code to be, multiple codes are available in this. You can see here Euro code, American code, ACI, British code. So I will just select BSS shapes and click on open, and in BSS code there are multiple number of I sections available in this list. So I will just change my material to S275 here, since I want my frame sections to be of this material. And for beams I will select one of these sections, which is UB, universal beam, and for columns I will select universal column sections. So at first we can select any section as a trial section and see if it passes or not, and we can always optimize it at a later stage, which we will see in our videos to follow. So currently I will select my beam to be UB, let's say 350, let's say 305 by 165 by 46. So I will select this beam and I can change the color. If from this option I can change the color, and you can see all these properties for that this particular section is shown in these windows: the outside height, the flange width, the flange thickness, similarly bottom flange width and thickness. All of these properties are shown here. I will click on OK, and to add the column section I will again click on import new property, click on I section again, change my material to S275, and let's say I want to assign a column section of UC 305, 305 and 137. I will click on OK. If you want, you can change the color from this option and click on OK. Now both my beam and column sections have been added, so I will just click on OK. Now to draw these columns and beams here, first I will draw only the edge columns and all the edge beams. So you can draw them either by selecting this line option, which is the fourth option in this menu, which says draw frame, or you can go to the top menu, go to draw, and the fourth option here is draw frame. So you can choose any one of them, and this window will appear where you will, to draw the columns, you need to select the column section, which is UC. So I will just click on the first point, starting point of column, and then click on the ending point of column, and to cancel the command I will just right click on the screen anywhere. Similarly, I will draw one column here, click on this point, then this second point, and right click anywhere on the screen. I will just draw these columns in the same way. Now all my edge columns are drawn. Now to add the edge beams I will select UB from this list, universal beam, and I will just keep on clicking these joints until all the edge beams are drawn. Now at the last point I will just now click right click on the screen anywhere to cancel the command. Now I will close this option. Okay, now you can see I have only drawn 4 columns and 4 beams here, but in this structure you can see I also need to have these center columns here, because this is a pretty long span of 20 meters. If I do not provide columns, the beams would be very heavy, these beams. So to control the deflection I need to add a few columns here. There are two approaches for this. You can either draw grid lines in the same way I showed you in the first step. You can either draw intermediate grids, but I personally think that drawing grids is a very time consuming process, and I usually do not draw all the grids. I only draw the basic ones, and then I use some replicate options, and I usually then draw my other frame members. So for that purpose, you can see there is a tick mark sign at the top which says set display options. You can select this option. The shortcut command for this is Ctrl plus W. So you can click on this option, and you can see the joints are currently not visible, or you can say the nodes are not visible. So to make them visible, you will uncheck this option and click on apply. Now you can see all the nodes where the different members are connected. See, these are the node points, and now they are visible. You can also go to the general options tab, and I want to differentiate between my member sections because I assigned beams a different color and my columns some different color. So I want to view them by colors of their section properties. So I will click on sections and apply. Now you can see I can view them by their particular colors which I assigned them earlier. Okay, now to draw the center columns, what I need to do is I will divide my beams in 3 equal parts. To divide them, I selected these 2 beams and I go to this edit option, edit lines and divide frames. Okay, here I want to divide my frames into 3. So I will type in 3 here and click on apply. Now you see SAP has already divided these frames into 3 equal parts and they have joined them by these nodes. Now I want to draw the columns at this location. For that I also need to have some joints at, or you can say nodes at, this bottom level. For this purpose I will just replicate these 4 nodes at this level. So to replicate, you can select the nodes and then click on edit, replicate. The shortcut command for replicate is Ctrl+R, and in the replicate option, since I know I want to go to this level, so I need to assign -5.5 meter in Z direction. You need to be sure that your units are in meter, so you can type in meters at this in this tab. If your units are in millimeter, you will have to type 5500 instead of 5.5. I will just click on apply. Now you can see my joints are replicated at this level also. You can also replicate joints by another approach. If I select these 2 joints and I want to replicate them, and this usually happens if I don't know the distance, exact distance. So I can also use this option of pick 2 points on model. If I click on this option and click on first point, I want to replicate my joints from this level. I will click on this joint to this level, so I will click on this joint. Now you see this replicate option has automatically calculated the distance between these 2 levels, which is, we know that, which is -5.5 meters. So I will click on apply and these joints are replicated at this level also. Now to add the columns, you will select this draw frame option, select columns, and I will just click on first node, second node, then right click, first node, second node, right click, first node, second node and right click. I will just close these. Okay, now I will draw all my main beams. These 2 were already drawn previously. I will just add my main beams at this location also. So I will click on this draw frame option. I will select my UB section and just join these 2 points. Now you can see my main members are already assigned in the structure. If I press Ctrl+W, or you can select this option from here, set display options. Now I wanted to see the extruded view of my member sections. So I will go to this general options tab. I will check this option, which is extrude, and click on apply. Now I can see the extruded form of my members. So here you can see my column sections are, the major axis of these columns are in X direction. But if I look at my structure, I can see that the structure is already pretty stiff in X direction. So what I need to do is I need to keep my major axis in Y direction. To change the major axis or to change the local axis of any member, what you will do is you will just select all these members and go to assign, and here you can select frame and go to local axis. By default these members are assigned at 0 degrees. If I change this angle to 90 degree and click on apply, now you will observe that the major axes have been shifted to y direction, which is desirable in this structure to control the drifts in y direction. So I will just click on close, and I think this is enough for today. In the next lecture, inshallah, which we will continue our model, and we will first define some cold form purlin sections, and we will assign purlins to our model. Then we will define the area sections and assign areas and loads to our structure. We will also assign the support conditions at this level. So I will just keep it short and precise so that it is easy for you to follow along. I hope you have understood this lecture, and if you have any comments or some queries, you can always put them or ask them in the comments, and inshallah I will try to answer them in my next lecture. I hope you will practice it, and one more thing, you can save your model by modeling up to here. You can save your model. Let's say I will save my model in this folder so that we can continue from the same location. So see you all next time, inshallah. Take care. Allah Hafiz.